Wetco Industries presents a Wetbike Video Service Manual. This video service manual presents actual demonstrations of procedures described in the printed Wetbike Service Manual. These demonstrations generally describe assembly and setup, troubleshooting, power head, drive unit, fuel system, and electrical system. For more information in some areas, please refer to the appropriate section of the Wetbike Service Manual. Note, if you haven't set the footage counter to 0 as instructed on the label after completely rewinding this tape, please do so now and restart. This will ensure quick location of any needed section. For the required section, please fast forward to the indicated footage. Digital counters may vary somewhat from this index. Therefore, we suggest you fast forward in search mode for easy section location. Assembly and setup. Shown first is the assembly and setup of the factory new wet bike in preparation for customer delivery. George Campo will demonstrate the installation of the rubber stopper, the capstop, and finally the front ski. He will then show how to adjust the handlebars for proper height, throttle grip installation, and steering adjustment where needed. Here is George Campo. First, you will need the rubber stopper and spiral pin. Position the rubber stopper properly at the rear of the steering tube and secure it in place with a spiral pin. Make certain the circle is in the down position. Then hammer the pin in place. When secure, swing the rubber stopper upwards to elevate the suspension arm and foot. Next, locate the stop cap and spray it with WD-40 or similar lubricant for ease of inserting into the steering tube. Some strong pressure may still be needed for complete installation. Now, locate the 4 bolts and the Allen wrench required to install the front ski. Note that it helps to balance the ski with your feet as you slide it into position. Hand start all 4 bolts before final tightening with the wrench. To adjust the handlebars, loosen the 4 10mm bolts as shown. Then adjust the handlebars to the desired position and retighten the bolts. Next, secure the throttle grip assembly by first positioning the cable around the front of the handlebars and sliding the grip into its proper place, using a Phillips head screwdriver to tighten the 2 screws. As we don't want play in the front end, it is important to look for side-to-side and back-and-forth movement. If adjustment is needed, loosen the 10mm clamp bolts and tighten the top adjustment bolt. Then retighten the clamp bolts. And place the wet bike cap in position. After adding battery water and filling the tank with the proper fuel mixture, the final assembly is complete. Troubleshooting. This section answers the most common troubleshooting questions experienced during wet bike use. More detailed information is also given in the printed Wet Bike Service Manual. These are the conditions to be discussed, listed in order of their appearance on this tape. Engine does not start, hard starting, engine misses and pops, engine backfires, engine lacks power, Pump lacks power or thrust. Exhaust malfunction. Engine does not start. Main fuse blown. If the engine does not start, examine the main fuse. If it is blown, replace it with a new one of proper amperage and check for continuity. If the new fuse blows, the rectifier may be faulty. This is checked as outlined in the service manual. Tether cord switch defective. The tether cord or switch may be defective. Examine the cord and the magnet, making certain the proper connection is made onto the tether switch. If the engine still won't run, lift the ignition panel and clip either wire as shown. If the engine runs, the switch is defective and both switch and wire must be replaced. Weak or no spark. If the engine still fails to start, inspect the electrical system for a weak or no spark. Look for a faulty CDI unit, which will cause a no spark condition. Check all wiring for possible shorts before installing a new CDI unit. Shorts can blow the new unit as well. The CDI unit cannot be repaired and must be replaced. Additionally, a malfunctioning primary coil may still allow the wet bike to start, run a few minutes until warmed up, then stop. Once cooled, it will restart, run for the same length of time, then stop again. This is a good symptom of a primary coil problem. Locate the coil under the flywheel and test it or replace it as outlined in the service manual. Further, though it rarely gives trouble, check the ignition coil as well. Additional symptoms may be the engine start followed by misfiring or firing on one cylinder or the same symptoms as for the primary coil. Look for any loose or broken wires, especially ground wires. Finally, check for a possible weak flywheel magnet. The easiest method is to substitute a new part and retest the engine. Fuel. Make certain the fuel pump is operating properly. If required, repair the pump with a rebuild kit or replace it with a new pump. Later we will go into more detail about checking fuel system components. Now examine all fuel lines for possible leaks, loose fittings, and cracks. Replace any part if necessary. Check the fuel filter for free flow. A non-standard filter element could be made of paper, which will swell if there is water in the line, thus cutting off the fuel flow. Inspect for this condition and replace the filter if required, making certain to use a new factory standard filter. Water in the fuel could cause a no-start condition. Also examine the anti-siphon valve for clogging or obstructions. Clean is required. Sometimes the fuel pickup line has fallen into the tank. Check for this condition and reinstall if necessary. Also check the weight at the lower end of the fuel line. If it is disengaged, the line can curl up into the tank and not draw fuel. Additionally, the carburetor passages could be clogged due to water or debris. Disassemble the carburetor and carefully clean it as recommended in the service manual. The fuel section on this tape clearly demonstrates carburetor disassembly. Also, a defective rectifier could cause a no-start condition. One symptom is the blowing of the main fuse when the ignition switch is engaged. Replace it if required. Another trouble area is the incorrect setting of the carburetor air adjustment screw. Check the setting by turning the screw gently clockwise until lightly seated. Then back off 1 1/2 to 1 3/4 turns. Also check for the proper 50-to-1 ratio of gasoline to oil mixture, as well as for fresh fuel. Sometimes old fuel can cause undue engine problems. If engine flooding seems to be the problem, look for a stuck or incorrectly adjusted carburetor float. Disassemble the carburetor, free the float, examine for proper adjustment, and then reassemble. This procedure is detailed in the fuel system section on this tape. Also check for the choke solenoid assembly for proper operation. A malfunction here can cause a flooded engine. This ends the engine does not start section. Hard starting, defective seals, defective choke assembly. Hard or difficult starting can sometimes be caused by defective seals. This condition allows loss of crankcase pressure thus making the fuel pump operation unreliable. Consult the service manual for inspection and replacement of these seals. A defective choke solenoid assembly can also cause hard starting. Check for proper operation. Engine misses and pops, water and fuel, damp wiring. When the wet bike performs well under a no-load or out-of-water condition, yet still pops and misses under load, there may be water in the fuel, especially if the wet bike has been submerged. Check the fuel system for the presence of any water. Again, if the wet bike has been submerged, make certain all wiring is dry and clean. Weak or defective plugs can also cause a missing condition, so they should be removed and inspected, replacing them if required. Please refer to the service manual for more detailed spark plug information. Examine the spark plug caps. They may be defective, as may be the ignition and primary coils. Check these coils for proper operation as described in the Wetbike Service Manual. Loose ground wires can also cause this same condition. Be sure and check them for continuity. Engine backfires, bare wire grounding, stator plate loose, leaking head gasket. Examine all wiring for possible worn or broken insulation, allowing intermittent grounding. Checking under the flywheel for this condition is especially recommended. While doing so, check the tightness of the stator plate screws, as a loose stator plate can cause backfiring. A leaking head gasket will contribute to backfiring and should also be checked. Engine lacks power. Blower fan on older models and choke malfunction. In older wet bikes, and especially at higher altitudes, the blower fan will sometimes create a slight vacuum in the engine box, causing an overly rich fuel mixture. Check for this condition by disconnecting the blower and test running the engine for normal power output. If it appears okay with the blower disconnected, try repositioning the blower hose further away from the carburetor intake and reconnecting the blower. Look for a jammed or stuck choke linkage. This will also create an overly rich mixture, resulting in power loss. The same can also be caused by the installation of an improper carburetor jet, so check for the proper jet size. Worn piston rings will cause power loss and can be easily spotted by a quick compression check. Consult the service manual for more detailed correction of this situation. Finally, be suspect of old or incorrectly mixed fuel. Make certain the fuel is fresh and properly mixed at a 50-to-1 ratio. Pump lacks power, defective wear ring or impeller. Lack of pump power or thrust is sometimes caused by a defective, worn, or damaged wear ring or impeller. Examine these parts together for such damage, wear, or debris. Impeller clearance should be no more than 0.010 of an inch. Obviously worn or damaged parts should be replaced. Also examine the rear ski, which might be damaged, loose, or cracked as shown here, thus causing flexing and allowing air to enter the pump. Cavitation will result. Tighten or replace as needed. Another area is the nozzle, which should be examined for damage, especially the stator vanes. Again, replace or repair. Lastly, double check for proper oil level in the gear case. Lack of oil can cause excessive friction and possible damage. Top off if necessary. Exhaust system malfunction, water in engine, exhaust cover plate under base plate. In some cases, leaking gaskets throughout the exhaust system can cause water in the engine, resulting in a no-start condition. If water is found without the wet bike having been accidentally submerged, leaking or broken gaskets are suspect. First, check the exhaust cover plate gasket located under the base plate and clearly outlined in blue. Replace if broken or cracked. Next, examine the exhaust cover plate gasket located on the power head as seen here. Replace it if necessary. You should also examine the muffler plate gasket located under the muffler canister as shown. Also replace if necessary. The cylinder head gasket may be at fault and should be inspected. Another trouble area may be the power head to base gasket and should be inspected for fault. the canister diffuser gasket can also malfunction. Remove the canister, inspect for leaks or damage, and replace with a new gasket if needed. Also, inspect the bottom exhaust plate gasket for any leaks or damage. Particularly note that this gasket is different from the exhaust cover plate gasket located under the base plate. Replace with a new gasket if necessary. Powerhead disassembly reassembly. This section shows the powerhead removal from the wet bike, followed by complete disassembly and partial reassembly. In order to stabilize the wet bike during powerhead removal, place a 2x4 on end about 5 inches from the rear ski as shown. Slowly remove the dolly and store safely out of the way. The wet bike is now ready for the engine pump removal. Locate and remove the 8 bolts on the bottom of the wet bike. Remove the seat. Now carefully disconnect both battery cables, securing them out of the way. This will avoid snagging of the cables when the engine is later removed from its compartment. Next, disconnect the main umbilical cord and also store it out of the way to avoid snagging. Disconnect the fuel line from the fuel filter. Use caution to avoid spilling. The engine is now ready to be lifted. Rock forward and out, raising the engine off the input shaft. Walk it slightly forward while standing it on its rear end. This will free the airbox for easy access and removal. Next, remove the 2 front airbox covers, thus giving access to the 4 bolts. Remove the bolts from both top and bottom carburetor. Then remove the airbox and place it aside. As shown, the throttle cable can now be removed by depressing the throttle linkage, removing the cable top from the linkage, and backing the assembly from its holder. Clear the loose throttle cable from the engine. Carefully lift the engine from the wet bike and place it on your workbench for easy access. To disassemble the engine, begin by loosening the flywheel nut. Once free, position the loose nut evenly with the end of the flywheel to protect the threads from any damage. Attach your flywheel puller and follow the usual procedure to pop the flywheel free for later removal. Now remove the flywheel puller. At this point, simply remove the flywheel nut and lift the wheel from the crankshaft. Sometimes it may be easier to use the puller for the initial lift against the flywheel's magnetic pull. Easy access is now gained for removal of the stator assembly. At this point, unplug all the color-coded electrical wires from the electrical components for simplification of further disassembly. Use an impact driver set to loosen the Phillips head screws securing the magneto basket. Which can then be knocked free with a plastic hammer. Lift the basket from the engine and continue disassembly by removing the starter and then the carburetor bolts. There are 2 for each carburetor. As shown, the choke solenoid assembly is secured by 2 of these bolts and should be removed at this time. Both carburetors, including the choke slide, are now removed as a unit. Now remove the 2 fuel pump bolts and disengage the pump. Remove the ignition coil and rev limiter. Pulling all associated wiring free of the engine. The electrical box can now be removed, along with its cover and ground wires. The rectifier and the entire electrical assembly is now removed, leaving a bare block. Disassemble the power head from the power base by removing the 9 nuts as shown. Lifting the power head will cause easy separation of these parts. Next, Remove the carburetor manifold by loosening the 10mm bolts as shown. Lift the manifold and reed plate away from the engine and set aside. Cylinder head removal is next. Loosen and remove all retaining bolts. Lightly tap the head free by using a plastic hammer. Once done, gently remove the water bypass spring and its fitting, storing them in a safe place. Now you can stand the block on its head and proceed with separating the case halves by removing all retaining bolts. A light tapping with a plastic hammer is usually all that is needed to break the halves free. Once done, set the case halves aside. Now remove the seals at the crankshaft bottom and lift out the crankshaft along with the connecting rods and pistons. Needle nose pliers are used to remove the circlip from each piston. A proper size socket extension can be applied to lightly tap out the wrist pin from each piston as seen here. After freeing the wrist pin, easily remove the piston, upper bearing, and washers. The second piston is disassembled in the same manner. Powerhead reassembly. Caution. Particular attention must be paid to piston ring positioning when reassembling the engine. The V-cut must be positioned away from the domed end of the piston in order to wrap around the piston locator pin properly, as shown here. First, carefully work the lower ring into position. Then install the top ring in the same manner. Caution must be used to ensure correct piston positioning. The arrow atop the piston must point toward the exhaust port for correct installation. Again, with the crankshaft, connecting rods, and pistons ready for installation, that arrow atop the piston must always point toward the exhaust port, which is the large plate with the 13 bolts. The piston is assembled to the connecting rod by inserting the upper rod bearing and both retaining washers on each side of the bearing. It will then slide as a unit into the piston. Next, reinsert the wrist pin. Securing it by reinserting the circlip using needle nose pliers. This completes the assembly. Now the pistons can be reinserted into the cylinders and the crankshaft seated into place. Make certain the main bearing stopper pins are in the upright position, or the crankshaft will not seat into the bearing races properly. The seals are now relubricated with a waterproof bearing grease, assembled together, and slid onto the crankshaft end. Which is held temporarily by a screwdriver as shown. The bearings and seals are then seated by removing the screwdriver and allowing the crankcase to drop into place. Lightly tap all 3 bearing pins into their locator holes as shown. Now check the crankshaft center seal, making certain it is straight and against the holding pins below. If not, this may cause excess wear. If not already done, clean the top case half. Coat the bottom half with a good case sealant as there is no gasket. Use caution for effective coverage. Too much sealant may later squeeze into the crankcase and cause bearing problems or plug fouling. The case half is then installed and pressed into place, installing all bolts by hand. Do not tighten any further at this time. The torquing sequence is in an X pattern and must be carefully followed. Starting with the 2 center bolts, begin torquing in an X pattern as shown. Working your way outward. This completes the block assembly. Now stand the short block up and check for freeness of the crankshaft by hand turning. Complete reassembly is simply a matter of reversing the steps previously shown on this tape. Drive unit. In this segment, we'll disassemble and inspect the drive unit and its associated parts. Reassembly is also shown. Disassembly of the drive unit begins by removing the 4 securing bolts and sliding the nozzle, and the wear ring free. Inspect for any wear or damage. If found, the parts must be replaced. Next, drain the gear oil. Remove both the bottom and the top screw, and allow the oil to drain into a catch pan. Next, remove the 4 bolts holding the radiator fins in place. allow the fins to come free. Holding the impeller shaft nut with a 1 1/4 inch wrench, loosen the opposite nut with a 17mm wrench as shown, and remove it completely. Now grasp the impeller shaft at the rear and tap gently, thus knocking out the bearing and its race in one unit from the opposite end. The impeller shaft is now removed. Secure the output shaft with vice grips at its base. Then loosen and remove the upper gear cluster with a proper wrench. The gear cluster will now come free in your hand. Inspect the rear bearing and oil seal for any damage. Also check the main circlip. If it shows damage, replace with new parts using a new circlip. Remove the 4 upper gear case bolts. It will come free by gently tapping up and down with the input shaft. Inspect the input shaft and its bearings by sliding off the top cap. Make certain the O-ring is serviceable. Replace any parts necessary. Inspect the front gear case cluster, O-ring, all bearings and their races for any damage or wear, and replace where needed. Closely check the shims on the back side for wear, replacing as needed. Examine all the gear teeth for wear points, cracks, or breaks. Again, replace as required. For gear case reassembly, replace the gear shaft and gear cluster by tapping in with a plastic mallet. Secure the 4 bolts. The lowercase gear cluster is repositioned onto the splines and secured with its bolt. The impeller shaft is then slid into position using caution not to damage any seals. Next, slide the front gear cluster assembly into place on the impeller shaft and gently seat the large bearing race with a plastic hammer. Reinstall the washers and the nut on the shaft end and tighten. Restrain the opposite end of the impeller shaft with a 1 1/4 inch wrench as previously described. Radiator fins are replaced as shown. Finally, add 90-weight gear oil and the drive unit assembly is complete. Fuel system. This section will demonstrate carburetor disassembly, inspection and adjustment, followed by the fuel pump and reed valves. First, remove all 4 screws securing the float bowl and lift off as shown. Take out the drive pin holding the float in place and remove the float. The main jet is then unscrewed from the tower top. The float needle is removed. Along with its seat. You can now clean the carburetor as recommended in the manual. Check for any debris or dirt while inspecting for any wear points. Especially on the needle and seat. Examine for sharpness. No marks or grooves should be seen. If parts appear to be okay, reassemble the needle and seat. Reinstall the main jet and tighten in place. Exercise caution with these brass parts as they can be easily damaged by over-tightening. Next, install the float assembly and drive pin. Now check the float for level. If adjustment is required, insert a small screwdriver as shown and twist, spreading the brass tab to bring the float up. Needle nose pliers can be used to squeeze the tab for reduction of the float level. This picture shows just how the correctly adjusted float should look. Next, the float bowl is reassembled with its 4 bolts, snugging them securely to prevent any fuel leaks. The second carburetor is treated in the same manner. Final adjustment of both carburetors is accomplished by turning the air adjustment screw in until it snugs up. Then back off 1 1/2 to 1 3/4 turns. The carburetors are now ready for reassembly to the block. The fuel pump is disassembled by simply unscrewing the 3 screws and carefully allowing the parts to separate. It's a 3-piece pump actuated by a diaphragm and spring. The rebuild kit supplies a new spring and both diaphragms. Just install the new parts and reassemble. If the fuel pump still malfunctions after this procedure, it might have an internal leak and a new pump must be installed. Next, inspect the reed plate, paying particular attention to the reed stops, making certain none are bent or out of line. A bent stop can easily be adjusted using an adjacent, correctly set reed stop as a reference. Inspect the reeds themselves for cracks or breaks. Any defective reeds can be replaced by removing the Phillips screws lifting away the reed stop, and installing a new reed. Reverse this procedure to reassemble. Next, inspect the gasket or O-ring around the reed plate and make sure there are no cuts or breaks. If all parts appear okay, the reed plate is now ready for reassembly to the block. Electrical system. For reference, we have isolated all the electrical components from the engine and arranged them for easy identification. Here we have the ignition coil with its two high-tension leads which connect to the spark plugs. Alongside is the rev limiter, which prevents the engine from over-revving in a no-load condition, such as out of the water. Next is the choke solenoid, which opens or closes the choke butterfly valve. The starter, as seen here, is a sealed unit with the attached bellows allowing expansion of inside heated air, preventing leakage around the seals. Directly under the flywheel is the stator plate, on which are mounted the lighting coil and primary coil. Here's the main power cord with its associated CDI unit and rectifier. The main fuse is easily accessible for replacement. Note that all connections are color-coded. Orange to orange, red to red, yellow to yellow, red-white to red-white. This completes the electrical segment and concludes the Wetbike Video Service Manual. We hope this tape has been useful in helping you become more familiar with the basic mechanics and operation of the wet bike. Thank you.